Well, hello and welcome all students. How are you guys? So in the previous classes, some basic concepts of chemistry, we discussed about the mole concept, concentration term, stoichiometry and limiting reagent. Now it is time to discuss about the laws of chemical combination. You know guys, whenever a chemical reaction take place, it always take place under some certain rules. It follows some certain rules and those rules are collectively called as laws of chemical combination. So now in this class, we shall discuss about the chemical combination laws like the law of conservation of mass, law of multiple proportion, law of reciprocal proportion, law of conservation of mass, as I said. And after that, I taught you about the empirical formula and molecular formula. What do you mean by empirical and molecular formula? How to calculate them? What are the questions that we will discuss in this unit? Alright, let's proceed.
Today's topic of discussion, laws of chemical combination. You know students, whenever there is a combination take place in chemistry, whenever any combination take place in chemistry between the compounds or the elements or the molecule, ion or the other species, it always take place under some certain rules, right? So those rules under which these combinations take place are collectively called as laws of chemical combinations. So in this today's class, we shall discuss about the laws of chemical combination. So how many laws of chemical combination are there? What laws we will discuss today? We will discuss about the law of conservation of mass, very easy, law of definite proportion, law of multiple proportion, 𝐿𝐿 law. We will discuss about the 𝐿𝐿 law of the volume, and then we will discuss about the Avogadro's law. We will also discuss about the Avogadro's law. After these law, we shall discuss about the empirical and molecular formula. So first start with the law of conservation of mass. What is the law of conservation of mass? Guys, it is very simple. Very simple. I'm telling you, it is very simple. What is the law of conservation of mass? It simply says that mass remain conserved. Mass can neither be created nor be destroyed. So during any physical or the chemical change, total mass of the product is always equal to the total mass of the reactant. That's it. Whatever the total mass of the reactant will be equal to the total mass of the product. This is very, very simple. Law of conservation of mass. The total mass remain conserved. In any chemical reaction, say for example, if I give a reaction, calcium carbonate gives CaO plus CO2. So if 1 mole of this will react, it will definitely give 1 mole of this and 1 mole of this. What is the mass of calcium carbonate? It is 1 mole is 100 gram, 1 mole is 56 gram and 1 mole CO2 is 44 gram. So in total mass is again 100. So mass remain conserved. Mass of the reactant is always equal to the total mass of the product. You can choose any chemical reaction. So during a chemical change, matter can neither be created nor be destroyed. Very easy. And total mass of the reactant is equals to the total mass of the product, which is 100 gram in the previous example. Alright. But one exception is there. You should note one thing. So that is considered as the exception of this rule. In the nuclear reaction, students, this law is not valid. Because in the nuclear reaction, some mass is converted into energy. Some mass is converted into energy as per E is equals to mc square. As per the mass energy relation of Albert Einstein, some mass is converted into energy in the nuclear reaction. So you can say that nuclear reactions are exception of this rule. So this is law of definite proportion. Students, what is the law of definite proportion? It is also very simple. It says the chemical compound always contain the same element that are combined together in a fixed proportion by mass, irrespective of its source. Now let me tell you in the simple words, what is the law of definite proportion? Do you know what is carbon dioxide? Carbon dioxide is CO2. What is the ratio of the mass of carbon and oxygen in CO2? It is 12 gram carbon reacts with the 32 gram oxygen. So the ratio of carbon and oxygen in CO2 is 12:32. Now we can produce CO2 by so many ways. We can produce it by so many different reactions. Like say for example, I say C plus half O2 gives CO2. I say CO plus half O2 gives CO2. Please let me correct myself. It is not half O2, guys. It is oxygen. C plus O2 gives CO2. CO plus half O2 gives CO2. Or you can say CO plus 1/3 O3 ozone gives CO2. In this reaction, CO2 is obtained by carbon and oxygen. Here it is obtained by carbon monoxide and oxygen. Here it is obtained by carbon monoxide and ozone. But still, in all three examples, ratio of the mass of carbon and oxygen is always 12:32. 12:32. This is the law of definite proportion, students. Always remain fixed. You can take one more example of this. For example, if SO2 is produced, in SO2, what is the ratio of mass of sulfur and oxygen? Sulfur is 32 and oxygen is also 32. So if you produce SO2, S plus O2 gives SO2. Ratio of the mass will be 32:32. Or you can produce it by any other means, by any other reaction, by any simple reaction. Its ratio of mass will remain same, 32:32. But you know, one exception is there. One exception is there of this rule. Suppose you produce water. You produce water, H2O, by using H2 plus half O2 gives H2O. And if you use the isotope of hydrogen then, or you use the isotope of oxygen then, another reaction is H2 plus half O18. This is O16. This is O18. So now it is H2O18. This is O16. Now the ratio of mass was 2:16. And here the ratio is 2:18. So this law is not valid in presence of the isotopes. Remember, right? Now the next is the law of multiple proportion. What is the law of multiple proportion? First you read the definition. When the two different elements, please listen carefully. When the two different elements combine with each other and form two or more than two compounds, then the different mass of one element which combine with the fixed mass of another element bears a simple whole number ratio. I know it is, it seems quite difficult to understand this one, but believe me guys, it is very easy. Once I'll give you the live example of this, it becomes very easy. So example number 1, sulfur and oxygen. Sulfur and oxygen togetherly they form two different compounds. When sulfur reacts with the O2, it gives SO2. When sulfur reacts with the 3/2O2, it gives SO3. Now in the SO2 and SO3, what is the mass of sulfur and oxygen? Here it is 32 and here it is 32. Here also it is 32 and here also it is 48. So mass of sulfur is same. Same mass of sulfur reacts with a different mass of oxygen. Then these different masses are in the simple whole number ratio, 2:3. This is what law of multiple proportion says. Now you read the definition one more time. When two elements combine, see, what are the two elements? Sulfur and oxygen. They combine and form two or more compounds like SO2 and SO3. Then the different masses of one element, this is the different mass of one element, which combine with a fixed mass of another element, this is the fixed mass of another element, are in the simple whole number ratio, 2:3. This is the law of multiple proportion. This is the law of multiple proportion. You can also give one more example. For example, hydrogen and oxygen now I will take. See, hydrogen and oxygen, they togetherly form H2O and they also form H2O2. Now what is the mass of hydrogen here and what is the mass of oxygen here? In the H2O, mass of hydrogen is 2 and H2O2 it is again 2. But in H2O, mass of oxygen is 16, but here it is 32. So now again, as per the law of multiple proportion, I'll say when the different masses of any element, you see students, these are the different masses of oxygen. When they react with the same mass of hydrogen, these different masses are in the simple whole number ratio, 1:2. This is the law of multiple proportion. Again, let me tell you, when two different elements react with each other and form two or more compounds, then fixed mass of one element reacts with a different mass of another element, then these different masses are always in the simple whole number ratio. This is what law of multiple proportion says, students. Now the 𝐏𝐿 law of gaseous volume, it is very easy. It simply says when gases react with each other, they do so in volume that bears a simple whole number ratio. So when gases react with each other, they always react in the simple whole number ratio of the volume with one another. And in case if product is also gas, that will also be in the simple ratio of the volume. So gases react with each other in the simple whole number ratio of the volume, and if product is also gas, that will also remain in the simple ratio of the volume, provided the fact that temperature and pressure remain constant. This is the condition. So provided the temperature and pressure remain constant, this law is applicable. Now here is the example of this law. When nitrogen and hydrogen react with each other and form ammonia in the Haber process, what is the molar ratio of nitrogen? 1:3:2. So this is the molar ratio of nitrogen, hydrogen and produced ammonia. So according to the 𝐏𝐿 law, the molar ratio of the gases is equal to the ratio of volume. Now ratio of volume will also 1, 3 and 2. So I can say that 1 liter of nitrogen reacts with a 3 liter of hydrogen and it will produce 2 liter of ammonia. 1 liter of nitrogen reacts with a 3 liter of hydrogen and gives 2 liter of ammonia. This is what 𝐏𝐿 law is all about. Alright. Now the next one is Avogadro's law. What is Avogadro's law? It was given by the scientist Avogadro, definitely. And it says, under the similar conditions of pressure, temperature, and also volume, under the similar conditions of pressure, temperature, and volume, for ideal or perfect gas, they contain same number of molecules. They contain same number of moles and they also contain same number of molecules. So under the same conditions of pressure, temperature and volume, let me tell you one more time, if the pressure, temperature and volume remains constant, then number of molecule will also remain same. Say for example, we have three gases A, B and C. Now for these three gases A, B and C, you see students, volume is same, pressure is same and temperature is also same. Then their quantity will also be same. 1 mole, 1 mole and 1 mole. You can also derive this law with the help of ideal gas equation PV is equals to nRT, which you will see in the another chapter, some gaseous concept. PV is equals to nRT. When P is constant and V is constant and T is constant, R is also constant, the number of mole will remain same. It will also become same. So this is Avogadro's law. So students, these were some law of chemical combination. Now I will tell you something about the empirical formula. This is also important. Examiner used to ask question from empirical formula in the competitive examination like JEE and NEET. So what is empirical formula? What do you mean by empirical formula? Empirical formula of the compound is the simplest formula. It is what? Simplest formula, which gives the simplest ratio in the whole number of atom of different elements present in one molecule of the compound. So in one molecule, there are constituents and those constituents are present in the different ratio. So whatever the simplest possible ratio of the constituent present in any compound or molecule is called as empirical formula. And it is point to remember, always remember that empirical formula does not indicate the actual number of atom. It gives the simplest ratio of atom. It is not equal to the actual number of atom. Actual number of atom might be something different. Now I will give you some example to explain what is empirical formula. In this example, you see, you know what this compound is? H2O2. You all must be knowing it is hydrogen peroxide. In the hydrogen peroxide, this is the real formula of hydrogen peroxide, actual formula of the hydrogen peroxide, H2O2. This is molecular formula. The actual ratio or the actual formula is molecular formula. Now in this molecular formula, what is the simple ratio of hydrogen and oxygen? It is 1 and 1 because the ratio is 2, 2. That is the actual ratio. But simplest ratio is 1, 1. So this 1:1 is the simplest ratio of hydrogen and oxygen. And this will be called as the empirical formula. So this is the empirical formula of hydrogen peroxide, HO. Another example. This is very, common example and you will understand it in a very simple manner. Guys, what is this molecule? What is this? This is glucose. This one is glucose. What are the components of glucose? Carbon, hydrogen, and oxygen. How many carbons are there? 6. Hydrogen, 12. Oxygen, 6. This is the molecular formula. This is the actual ratio. 6:12:6. This is what, students? Actual ratio. This is actual. And what is the simple? If you take the simple value, 6:12:6, it will come 1:2:1. So this is the empirical formula. Simple ratio. Simplest possible ratio. C1H2O1. This is the empirical formula of glucose. And it indicates that the ratio of carbon, hydrogen, and oxygen atom in the molecule of glucose is 1:2:1. It is 1:2:1. And it is called as empirical formula. Now, many times you will see examples or numericals in question in which you have to find out the empirical formula. So, how to find out the empirical formula? Now, suppose I am giving you one example. An organic compound on analysis was found to have the following composition. We have any organic compound, and when we analyzed this compound, we found that it contains 6.7% hydrogen, 40% carbon, and 53.3% oxygen. Alright, so this is the composition. Now what you have to do in this example? In this example, students, you have to find out the empirical formula. And how you will find out the empirical formula? Percentage of different elements are given: hydrogen, carbon, and oxygen. Now you please follow the steps which I tell you to find out the empirical formula. In order to find out the empirical formula of the same compound, what you will do? First, you will form a table like this. To calculate the empirical formula, let us make a table like this. First column will be of element, then percentage of the element, what is the mass percentage, then what is the atomic mass, then we will calculate the number of atom. I'll tell you how to calculate the number of atom, and then the simplest ratio, right? So here we go. Let us write the given information about carbon in the table. So first I will write the information of carbon, say for example. So the element is carbon. Percentage mass given is 40 and atomic mass is 12. Now we will do it for the another elements. Similarly, we did for carbon. Now we will do it for hydrogen. Hydrogen is the another element. Its percentage is given 6.7 and atomic mass of hydrogen is 1. So first column is element, second column is percentage, which is given in the question, and the third column is atomic mass. Carbon 40 and 12, hydrogen 6.7 and 1. Now we will give the inputs of oxygen. Another element is oxygen. Mass percentage is 53.3 and atomic mass is 16. So now in this table we have filled all three elements: carbon, hydrogen and oxygen. So let me tell you one more time. What will be the order of the columns? Element, then percentage. What is the percentage? For carbon it was 40, for hydrogen it was 6.7, and for oxygen it was 53.3, which was given in the question. In the different questions, these value might be different. Atomic mass is the next column. So atomic mass of carbon is 12, for hydrogen it is 1, and for oxygen it is 16. Now we will calculate the number of atoms in the next step. So how to calculate the number of atoms? In order to calculate the number of atoms, students, if this column is A and this column is B, we will do A by B and we will take the simplest ratio, A by B. So we will divide the atomic mass of each element in its percentage mass. We will divide 40 by 12. We will divide 1 in 6.7 and 16 in 553.3, like this. Let us calculate the number of atoms of carbon, hydrogen and oxygen as well by dividing the percentage mass by atomic mass. So when you divide the percentage mass by atomic mass, you get the number of atoms. By dividing 12 in 40, you will get 3.3. By doing this, you will get 6.7. And by doing this, you will get 3.3. This value will be there, 3.3. Now you will take the simplest ratio. Out of 3.3, 6.7 and 3.3. Which one is the smallest possible value? Lowest common factor. Which one is the common? So 3.3 is the common factor and lowest also. So we will divide 3.3 by all the values like this. 3.3 by 3.3 is 1. 6.7 is 3 divided by 3.3 is 2. Now some of you might be thinking that, sir, 6.7 divided by 3.3 is not 2. It is somewhat more than 2. So let me tell you guys, in these kind of numericals, we neglect it. If it is coming 2.05, then we will consider it as a 2. If it is coming 2.1, we will consider it 2. Yes, but if it is coming 2.5, then you should not consider it 2. If it is coming 2.5, then you should consider it 5 by 2, right? So you do the round off. In this, you do the round off. Now the simplest ratio is 1 is to 2 is to 1. It comes what? It comes, guys, 1, 2 and 1. And this is the empirical formula. So the empirical formula of this compound will be C1H2O1. The C1H2O1, the simplest ratio, 1, 2, 1. This is the simplest ratio, students, and this will be equal to the empirical formula. Now to get the empirical formula, write the symbol of the element present followed by the numbers obtained as the simplest ratio, like I did at the top of the slide in the subscript. So this is how we calculate the empirical formula. I hope you got it. This is the empirical formula of this organic compound CH2O. Can you tell me, this is the empirical formula of what? This is the empirical formula of glucose. I told you in the example, C1H2O1. So one more time, first column is element, then is the percentage mass, then atomic mass. Okay. When you fill these columns, then you do what? You calculate the number of atom. How you calculate the number of atom? You divide the atomic mass in the percentage mass. Then you will get some figures, and then you take the lowest common factor and get the simplest possible ratio. And that simplest ratio will be equal to the empirical formula of the compound. So this is how you will get the empirical formula of the compound in the given question. And the last one is the molecular formula. So what is the molecular formula, students? Molecular formula, as I told you, it denotes the actual number of the atom of the different element present in the compound. This is the actual number of the atoms, like C1H2O1. This is the empirical formula of glucose. But what is the real formula of glucose? This is empirical. But the real formula is C6H12O6. This is molecular formula. So like I told you earlier also, molecular formula is the actual number of actual number of the ratio of the component elements. All right, students. So this was all about this class, and in today's class we studied about the laws of chemical combination, how the chemical reactions take place under the influence of different chemical laws. And then we studied about the empirical formula, how to calculate the empirical formula and molecular formula. I hope you understood the topic. Please keep watching and keep studying. Thank you so much.